Where are you, programmer box? Ugh, on the floor. Alrighty. Wow, where is everybody? Nobody's here. That's because I don't live stream very often anymore. And everybody said, stuff you, Mr. Daniels, we're not turning up anymore. You've abused our loyalty for too long. Hey there, Ashes. Alrighty. Dreams. Raj. Alrighty. Anyway, I got a package from Ali this morning, so that's kind of curious about this thing. Don't know if this is going to be any use to me or not, but kind of thought I needed a little chip holder or a little chip vise that was better than the one I used to use where you just have the two parallel sides coming in. This one seemed like it might be slightly better. Hey Draco. Come on. Out you come. It's all on the high side. That's better for me. I mean, I get the appeal. Let's see, zoom up. It would have been maybe better if it pivoted underneath the center of these jaws, so that when you spin it around you don't have to shift it, to keep it under your microscope. Then again, maybe that's what they're using this for, but that's not central pivot either. So what is? Central pivot seems to be about there. Let's see how... Yeah, they're a bit sloppy. Geez, I wish they'd use a tighter thread on this stuff. I mean, I understand that they've probably gone for a coarse thread just to make it fast. But if they're going to go for a coarse thread, can they improve their tolerances slightly, please? Yeah, that's pretty sloppy. I know I'm not going to be able to really get any better anywhere. But that sloppiness can become an issue, like if you're up here, you're trying to hold that chip tight and you clamp it down, it sort of pivots off a little bit like this and things don't fit properly. I suppose one way I could improve it is to put some sort of packing material on the travelling nut. Oh well. Hey there, Pedro. So yeah, I mean, it's going to do the job. It will certainly do it better than the parallel jaws version that I've had for many years. But it would have been nice if they just put a little more money into making sure that that travelling nut was, just a bit better quality. I mean, you can have a fast thread or a coarse thread and still have good tolerance, but I suppose I could pull it apart and find out what I can do. Anyway, at least it's a good baseline to start with. Okay, what have we got here? This is the Apple power sort of cable thingy. I see they've even gone for the Apple style of pull threads. They won't do it as good as Apple though. Yeah, definitely nowhere near as good as Apple. Say what you like about Apple, but they know how to spend millions of dollars on making sure they get the perfect packaging. Hey there, Miles. Yes, I mean, that you'd get fired from Apple if you had that happen. Oh, stupid propaganda bullshit. Get out of here, I don't want your crap. Hey Warren, Gustavo. Oh, Lexi's here. Hello, Lexi. Didn't see you. How did someone else know you were there? Interesting. Why have they got 3 separate wires there? That's intriguing. Yeah, I'm not sure why they've got triple wire going on there. I would have thought a nice, solid, high thread count wire would have been better. Okay, decent buttons at least, it seems. Want to swap jobs in the middle of doing a 15 Pro Max? Oh god, no. Can't you just, don't they just come off with a bit of adhesive now, like the 14s? Okay, so we got the god-awful spaghetti octopus leads again. I genuinely prefer single lead solutions. Like, I don't care if I've got, 20 of these individual ones. I just prefer to have the single lead solutions up. One connector, one lead. Because this stuff, when you're trying to work on the job, it tangles up elsewhere, gets annoying. But what I'm hoping I might be able to do is find a way to reappropriate. I don't know. And I know they've got 4 ports here so that you can just plug it all in at once. But honestly, it looks like some sort of sex dungeon whip or something now. No? Can't show that to the kids. I mean, I suppose it covers everything. I guess I'm asking too much. Just, yeah. Now, what's the power? Does this regulate its own power? I don't think this regulates its own power. I have a feeling this still depends on you putting 4.2 volts in. Did I not see destruction somewhere? Quality control. You really think they quality control this? No, they ain't. They just stick this in the box. They're like, I swear there was instructions, weren't there? There's nothing in these. Looks like I'm deluded today. Yeah, stickers and no manual. I mean, it's I mean, not that I need a manual, but it would be nice to verify the specification or the minimum requirements. Like, do I have to put 4.2 in myself? I'm guessing I do. Oh, here we go, we've got instructions. Let's see, 3.8 to 4.5. Okay, so yeah, you got to supply the voltage, which is not too much of a problem. So what I might try and do is create a I've got a couple of choices. I can either create a bridge board that will go from USBC and then regulate down to 4.2, and then that way I can use the data off my what do you call it? Actually, I can already do that, to be honest. Precious DT880. Okay. Hey Serge. Greg, Gustavo, not having fire. Okay, so this is my version of the DT880. So what I can do is plug the power in, and it's got the power and boot button, but yeah, I reckon I could probably modify this to have a USB-C variant, and I can probably plug these in, these cables. Anyway, I should be able to do this. Input power. Okay, so this one regulates to 4.12. The nice thing is it shows up on my USB-C meter. Let's find ourselves a logic board. What have I got? This is from 10s upwards, I think. So I've got a 12 Pro, 11 Pro, 13 Pro, XS. We'll try an XS. Now, of course, the thing is, through this device, which is showing power on through the USB-C meter, you're not going to get to see the voltage. You're only going to get to see the current, and most of the time that's all we care about anyway, because these things are just battery simulators. Okay, so this is an XS, and you see what I mean already. The cables are being a pain. You can't find what you want in a hurry. They really would be better off just having one port on here, having a built-in regulator so that you can then plug this into anything up to like 10 volts or something like that. But that's just my personal preference. Obviously some people are perfectly fine with having annoying octopus, but they just keep tangling on each other. Okay, XS. Yeah, it gets in the way, it's annoying, blah blah blah. We'll turn off the power for the moment. Okay, so it obviously goes on this way. But I wanted to see what this thing was like. You know, it's a popular option. Okay, so got power there. Okay, that 20 odd milliamps that you can see, that will be probably from this, I think. Let's see. Nope. Oh, I know what it is. It's the internal regulation of this one. Alright, so let's see if we got power. Okay, we've got power on. Drawing 2 milliamps. Boot. That does the job. Seriously, Greg, you're having the worst luck in the world when it comes to AliExpress. Okay, so this is working fine. I mean, realistically, I don't need this device because this device does all, does the boot and all that. The only thing I need are the cables. So what I need to do is find out how they're doing the boot simulation. Like, it'll just be one of these lines that they just pull to ground or they send up to 5 volts or whatever. And then once I know what that is, then we can use these octopus leads, and more than likely whatever technique they use on this is going to be the same as pretty much everybody else in the market, because they're all going to copy each other, much the same as what they did with this setup. Because for all the other devices we had these plug-in options, and then even though that's a USB connector, it wasn't really. They fiddled with the data plus data minus lines to do the boot simulation, things like that. Anyway, so I might see what I can come up with. Maybe I can make a new variant of this that has USB-C connector for these cables. The biggest thing that I'm running into with this DT880 simulator replacement is that I want to be able to have it switch over to a current limited mode when it exceeds the 3 amp threshold. So I want it to be able to like go, okay, we've got a short somewhere on the board, but instead of just dropping out completely, I want it to sort of drop down to say 1 amp peak, and that way then you can track the fault, which will probably get you to the MOSFET, the PP back MOSFET, but nonetheless it'll allow you to then keep working on the board rather than having to keep hitting the power button. Anyway, so the cables work. That was more than anything else, is I really wanted to try these cables. This here, honestly, it's extraordinarily sophisticated inside apparently, and I'm not sure why. Because if all it's doing is sending... yeah, I'm going to have to put this in its own separate box. If all it's doing is sending the same signal for the boot and whatnot through, then yeah, I don't know. So I'm going to pull this apart. I'm going to ruin my warranty that I never had and pull this apart. So what are you, T5 or T6, I think? Hey John, T6 it is. Because I know in their sales pictures and things like that, what the that's rounded out. Little bastards. How do they round that out? And I haven't even had a chance to... wow. Okay, warranty sticker violation. Right through his head. Hey John, glad there's a stream. You're having a bit of a rough one, are you? I need to build a bunch of USBC and USBC meters and ring lights today. I need to get that done. I've got people who have ordered and I haven't been able to ship out because I didn't have any stock left. So we've got a double board construction in here. Seriously? That's pretty crazy over the top. Right. Usual drama that you get with every mechanical device that you've got to unscrew. So you get every screw out except for one. So what are we going to do? Well, since this is Chinesium material, we're going to have to use Chinesium screwdrivers. I'll find out where I'll put my Chinesium screwdrivers. I think they're in my other workshop. Oh, they're in here hiding. That's a 10. That's technically too big. Now you see these are supposed to be T6. We've got 9. That's not going to work. I thought I had a T8. No. Alright, we might actually have to go hex drive. In fact, they probably are. They probably are hex. And I just blindly shoved a Torx into them. Let's see. There we go. All right. So. Oh, you're going to be trixies. Never easy. Okay, so we've got this little plastic indicator getting in the way. Does that mean we've got to go the other way? No, we definitely got to go through this way. But it means that little plastic thing has to come up. Wow. I'd say what they do is they assemble this and then they install this little light channel, and it's like heat or glued in, and it basically locks the board. So what we're going to do is we're going to cut these little things off and it should slide out. That should about do it, actually. There we go. Yep, as suspected, this is nothing at all like what they show on their website. Nothing at all. The sophistication is zero. I'm going to have a look at their website just to verify that I wasn't dreaming about this. Sorry, I'm just trying to... and switch to schematics. Alright, so this is what it's sold as. Let's see if I can find... Here we go. It's not too dissimilar, actually. Yeah, no, I'm wrong. I was thinking of something else. So I am wrong there. There you go. I'll admit it. I swear I've seen a picture where it is a vastly more sophisticated looking board in there. Maybe it was a different one that I was looking at. But yeah, no, it is the same as what they're showing here. So my bad there, my bad. Anyway, so basically what we have is, yep, see, I don't know why we've got 3 wires, but we do. They're all grouped together, fair enough. And then of course we've got this here. And God, let's fix up some of the QC manufacturing issues here. Probably shouldn't actually cut at the solder wick point, but that's what we're going to do. That's a really shonky joint there. Oh, God. It got me right in the throat. Nice. Okay, so they're using the 6-pin style USBC connector. That's cool. Nice and easy. clean up these ones too. Yeah, that's some shonky solder in there, folks. Another one in the throat. So basically, I would hazard to say that, okay, I'm going to guess we've got V plus ground, and then these two, we've got a little veer here. Which one are you going to? I would not be surprised if I could put a USB-C to USB-A adapter onto these leads and it might still work. I reckon we should try it. I'm trying to work out, man, that solder has barely wetted itself onto the board, onto the connectors. It's worse than my, what's going on here? Oh, right. Interesting way they've done this. I don't exactly know why. I suppose they wanted a gapping there. I'm not sure why they bothered with having this entire board. Maybe it's just easier for stability in the channeling. Okay, we're just going to find out which button does what. So this button here is the boot button, so that's really the one that we care about. And like I said, all it really does is just pulls the line to V plus. V plus being, I'm trying to work out how I want to do this. Okay, so you're V plus, and you should be 2. Yep. So it's either going to be that pair, if I can press the button. No. Nothing. I'm disappointed in myself. Can't be the other one. You should be ground, aren't you? Okay. Yeah, it's definitely ground on the outer. Okay, no. Okay, so that's V plus. Maybe it's shortened to ground. Ugh, nee. Alright, maybe I have to plug it in and see if we can get something. Alright, plugging it in time. Okay, power is on. Don't use continuity pull. Voltage mode. I'm just going to measure, we'll see what voltage they're putting out. It should be the same as what's on my meter. 4.12, and yeah, that's actually in agreement. My USBC boot thing is 4.125 or something. Right, so what I want to see is which pin actually gets, what have we got? Nothing there. There we go. That's interesting. That's, yeah, okay, that's pulling it to 5. Oh, I know why. Okay, so that is probably a boost chip. I think someone said they might be using flying cat boost chip. And so it boosts it to 5 volts, which then, yeah, goes onto that pin. Shite, what pin was that again? Okay, it's that pin there. What about this one? Okay, it does both of them. Alright, so the two inner ones get pushed up to 5 volts to force the boot. And the reason why it does that with the two inner ones is because that simulates you plugging your USB charger into the phone. That's the whole point of it. And that's why it's 5 volts. Now I do exactly the same with mine, except instead of boosting, I'm already using the 5 volts that I'm getting in through the USB-C. So I just basically pull the line up off the USB-C line. So yeah, it's the same thing, nothing sophisticated. They just went a little extra here because instead of them dropping a voltage, they're boosting a voltage. So that now we understand it. So it's a little boost chip as opposed to a buck chip. Which means that, yeah, we should be able to do that conversion. Let's see if we can. I don't know if this is going to work or not. Should I sacrifice my excess just in case I do something wrong? I mean, hey, this excess board has been sitting in my workshop for eons now. I find it very difficult to let go of working equipment like this. What am I doing? I don't need this. This is not what I need. This is what I need. Okay. Alright, we may have an explosion or we may have everything go okay. So power. Okay, we're not getting a short, so that's a good start. Boot. Okay, it's not. No, that doesn't work. Okay, so much for that theory. Oh well, doesn't matter. Anyway, the point is, it's going to be very easy for me to modify this unit. Put a USB-C connector there, or I can maybe even put it on top. The only issue is going to be that I have a USB-C for input. And so then now you've got two ports that look the same, that have different purposes, and that's a little bit of a dangerous game to play when it comes to design. I'll have to have a think about that. It's because, yeah, you may think, oh, no one's going to mess that up. Believe me, they will. They will mess that up. They will put that backwards or something like that. Alright, so a bunch of cables. Yeah, I suppose I better put back together, eh? So as a freestanding device, yeah, I mean it's fine. Like I said, I just personally prefer the octopus cables. Like I said, I do personally prefer them to be individual cables per device. But I guess for some people they're like, well, I don't want a dozen cables floating around. Much easier for me to only have 4. So it's a personal preference thing, I guess. Oh wow, not even close full. Not even remotely close. Too big. Just right. Goldilocks. what I should really do is use this device but change the programming on my power supply, the little on-screen display you got up there, so that that display has a logging meter. Much like I have with my USBC meter. I guess for me, I'm just trying to get away from having to use a DC power supply as much as I can these days. It's so convenient just relying on USB-C now. Okay, what's going on here, folks? Not sitting in perfectly. Surprise, surprise. I do have the microwave, I don't have the lab coat. Can't believe no one in this town has for sale fresh lab coats. I don't want to use a second-hand one or anything like that. Lab coats are the sort of thing that you really should not use second-hand, because you don't know what chemicals are being sprayed on that thing. Oh look, I left some hydrofluoric acid on here. Whoops, my bad. Not likely, obviously, but you know what I'm saying. Yeah, there can be enough remnants on there that it can give you a bad day. Alright, get in there. See, now I'm trying to pack these octopus leads away. What a pain. Okay. Quit your whinging, Paul. Get on with the job. Okay. Alright, third item. Oh, for the cats. Thank you, XX. AIX. More cat food. Actually, we did just get some boxes of cat food today. Some high quality kibble for them. Very low carb count in them. Good ingredients, that sort of stuff. It's expensive stuff, but yeah, it saves you in the long run in terms of vet bills and stuff like that. Thank you very much for that. I don't have a haircut, by the way. I've just got a long hair tied back with a girly ponytail thingamajig. Okay. Alrighty. A few of you already know what this is. I'm just kind of curious to see how. Yep, it's 341. What's with all the bridging? Okay, so wait, where's pin 1's up here? I already actually have one of these. Yep. Okay, the reason why I've gone out and bought one of these is simply because, well, they're dirt cheap. Disturbingly cheap, actually, for what you get. And, oh wow, they even put little pads on the back. Yeah. The ZIF socket is acceptable enough. So I kind of wonder if it... Oh, what? Why don't you... Oh, you're locked. Right, okay. Duh. Cute. The only thing is, how do I actually use that? Okay. What are these really good these days? Back when I was doing model aircraft electronic stuff, and most of the chips that I was using were the SO8 Tiny 13s and things like that, the only supplier of these sort of clips was 3M, and I think it was like $20 a clip or something like that. And I would have to use them to program my devices because the boards that I was working on were too small to put an ISP header on it. So you had to build the device, put the clip on, and then flash it. Of course, the other way is if I just simply had pre-programmed the devices, that would have been the smarter thing. But sometimes when you're doing testing and things like that, you just didn't have the opportunity to pre-program. So yeah, you'd buy these SO8 clips, and I would go through them pretty much every month. I would have to buy a new one because the plastic lock teeth that are down here that hold underneath the chip, they would just wear out, and then of course your clip would just slip right off. So anyway, the fun old days. Glad I don't have to deal with that anymore. This of course is the easier way now. Just push down like that. Interesting. And none of those things compare to the usefulness of one of these Harold purple adapters. Now, the downside is that they're using a USB-A. I suppose it's useful because they can just plug straight into the device. Not for me though. I need an extension lead for USB-A. And what's the bet that I've thrown them out in a fit of disgust about how awful their quality is? Come on, I know I've got a USB-A extension hanging up on my wall of glory here. There we go. Not a very long one. Might just be able to reach. Oh man, there are all kinds of mess here. Anyway, I've got a chip on there, so I'll plug this in and see how we go. This is schematics. Let's see if we plug this in, if anything comes up. Come on, I've only got one slot left on my hub. Get in there, gotcha. Nothing. Seriously? You're gonna play that game on me? Or is it just a really bad... Is there something I have to do to this? Are there any LED? There's a little power LED. I think the cable is bad. Yeah, I'm pretty sure the cable is bad. I'll just try another cable. Actually, you know, I'll just plug it straight into the machine and see if at least that'll give us our... Oh, we can't. Nope. Oh, blimey hell. Try this. Okay, I think we got something. Do we get something? We have. And marvelous. Hilariously, there's really... Yeah, okay, 1A865512. Yep. That's CH341. So now I've got to find out how to use this in Linux. Let's see, CH341 programmer software for Linux. Oh, neat. Visual stuff. Woo-wee. Don't normally get that. Okay, but this seems to be more for... Yeah, this seems to be. Hopefully, it's not just for those chips, because that's no good to us. We've got so many more. Oh yeah, this looks promisingly dubious. Unless it's French or something. Hey, Mr. Howe, Paul, good to see you. I've been wondering where you've been, and thank you. Thank you very much to Paul Howe for your contribution of $100 for lots of cat food, I dare say. Thank you very much for that, Paul. We had a fun event, I think it was on Monday, where one of our, what was it, I'm trying to think, trying to think who it was, Bear, who is one of the new nuggets from a year and a half ago. And we opened up the cat room because they get all locked up in 3 rooms up at the end of the house. And there was just vomit all over the floor. It was like a scene, okay, it wasn't quite, but it was similar to a scene out of Santa Clarita Diet. And we're like, what the hell? And we're looking around, and then we see that Bear is all kind of fluffed up, pale white nose, and not really happy about life in general. And yeah, it was just kind of weird, didn't know what to think. And of course, one of the concerns we have is that it is snake season at the moment, and even though they've been locked up all night, the thing is you can get a bite from the day before and it doesn't manifest any sort of symptoms until 12, up to 24 hours later. And so that was our very first thought. So we were lucky, we were able to get a appointment at the clinic very quickly, and we raced down there. It turns out he just must have eaten something bad, bad biscuit or a bad lizard or something, I don't know. Fortunately it was all good, but yeah, it's a sort of panic that you just sort of, you wonder at times what you have to do to try and keep them healthy. Like you lock them in for 12 hours a day, or keep them inside 12 hours a day and everything, and they still find ways to make you freak out. And we've been having a bit of a run to the vet clinic lately, and it's starting to wear down. Like obviously we had Micro with his lump on his abdomen. Thankfully that ended up being a case of, it looks like it was just a cyst. But you worry about these things. It was about 6 months ago I first detected it, and we had the clinic check it in casual passing because it wasn't doing anything, and they said they weren't 100% sure what it was. They couldn't really give any sort of definitive diagnosis, and we accept that. And they said, it feels like scar tissue or something like that, and I was like, that's kind of weird. But anyway, and then a few weeks ago we noticed it changed a little bit. So obviously we immediately took him down, put him in for surgery, which is in itself a major drama. But better to get it find out what we're dealing with, and turns out in this particular case it was thankfully just a cyst. So you never can tell. Yeah. So thank you very much, Paul. It is always appreciated. Okay, well, I hope you enjoy the rest of the stream when you watch it tomorrow. This is Rescue Kitten's in her first. Oh man, yep. It doesn't take them long to get onto the heat. We have now done around about 10 spayings, and actually more than that. Now I've got to count. So 2, 3. Yeah, 10 spayings. Expensive too, but you do it because it's a lot better to have them spayed than it is to have them running around getting pregnant, and that creates more dramas. Oh boy, what am I doing now? Oh, that's right, I'm trying to work out what to do about this software. Right. Okay, that's the chip software itself. X volt of white lab coat. Yep, I'll get high on that. Okay, CH341 prog. I wonder if the yeah. So I've got the software for the mini, now the TL866, which is great. It's just a little bit slow, and I thought I'd experiment and try something different. But I don't think that's going to support that. So we. It was real smart of me to buy something without first checking to see if, okay, go to this forum? No. Maybe it's this thing, IMS prog. Okay, well, it looks like we're going to go for IMS prog then. Okay, this looks more like it. What? Great. Now I have to install the Qt5 development kit. Ugh. Let's see. Apt install Qt libqt5. Oh. Whoops. Fine, we're going to go for the Debian package then. Fine, we'll use the pre-built. Oh wait, here we go. Oh, yeah, bit of extra reading of the instructions. Most of these I should already have. Not used to people putting instructions on their pages. It's like, yeah, it's just not normal. Okay, make minus J. What? Just do make. Jeez, it's a small program. No need to find out how many processes you've got. That's what this section here is. How many processes have you got? So, yeah. So it's nproc. 12 cores on this machine. Okay, so yeah, making some. And that should be it. So now we call IMS prog, hey? Whee! What? Not connected? How dare you? Oh, couldn't open. No. God damn it, I hate you, Linux, sometimes. I'm gonna have to set up permissions. That's a pain in the backside. Chip is not connected. Okay, that is actually technically correct because we have in fact not got the chip assembly on there. I'll just plug it in now. Okay, now it is, and now it's not going to fit. And we're back to the damned problem where we need a USB port. Yeah, that's not gonna fit. Wonder if we can bodge something. Let's see. Oh, I've got enough stuff around here. I'm sure I can bodge something. All I need is a USBC mail to USB-A thingy-jiggy-wiggy. Yeah, knew I had one around. Okay, and then we plug that into there, and then we hope smoke doesn't come out. Okay, we've got a power light. Cool. Oh yeah, and it's found it. There we go. Yep, it's found it. Okay, let's read. Oh, okay, fine. Why doesn't it just detect? Chip is not connected or missing. Why is it doing this? Detect. What? Hey, Diffbum. File IMS prog editor not found. Oh, seriously. What now do I need in my life? Oh, that's too fucking slow. I mean, that's too slow. Looks like I have to do another build. Oh, hell. Oh, wow. Well, right. Okay, hang on there. I've got to actually say what it is. Jeez. So this is an MX25 SPI ROM. This is the joy of, getting used to new stuff. This is why we generally don't change what we use too often. 25 EEPROM. Don't be like that. Seriously, where's the auto detect? Oh, great. So I don't get my detect now. Like I said, the only problem, it isn't even really a problem. The only sort of negative of the TS866 unit is just that it's a little bit slow. TL866, but other than that, it's fine. Let's see. I should not have to do any of this. Chip info. And if I do have to do this, I've got to tell you though, the command line way is actually easier. The 341A is even slower. That's hilarious. How can it be slower? Oh, sorry, thanks. I thought I actually had switched that, but anyway, guess not. Who knows what this is? Wow, they do not have a lot of chips here. There is not enough chips here to... yeah. Graham was complaining about it last stream. Really? I missed that one. I'm glad I only paid $7 for it. Because yeah, if you go to the mini prog program for the 866, it's got hundreds of the chips. This has got basically nothing. Okay, maybe we're getting somewhere here. Let's see. I don't even know what size it is. There is a new version of the... well, you get the Pro version or whatever, and that would be fine. But the trouble is, the ones that they sell you now are the ones that are locked. Let's see, 64... so 8 times 64, 512. Yeah, 512. Yeah, with the very new, faster, nicer looking 866s, they're all locked apparently. Yeah, is this 512K or 512 meg? I don't know. I have no idea what the page size is. What is the point of letting you set these when that overrides it? This doesn't even have a 64 option. Getting angry. Okay, we'll try that. Whatever, just read it. Error reading block 0. Hilarious! Yeah, without a well fleshed out database, it's pretty much useless. I have already read this particular chip. This is the chip from the microwaved board. Wait, aren't these supposed to be SPI ROMs anyway? Yeah, SPI flash. God, I'm an idiot. Right, that makes a lot more sense. Oh, why didn't you people tell me this? Okay, now we're getting somewhere. Let's see. L64. These are 7.3s though. Is that you, Milo? Read. Detect. That's okay, DefPom. There was someone trying to get a hold of you the other day. Who was it? Oh, Quentin. Quentin was trying to get a hold of you the other day. Q's is what he goes by around here. Yeah, that's it. Yeah, Q. Yeah. The MXIC 25L6473. You do. Go back there. Now, they don't seem to have the exact one that I have, but I would have thought this would. Error reading blocks. What's going on here? Okay, you talk to him. Okay, that's great. Excellent. Chip is not connected or missing. Oh, this. Alright. Maybe this is something to do with. You know, they were talking about there's TTL versus S something on the selection here. Kind of interesting, they're using a 12 megahertz crystal to drive the USB chat interface, whereas I use the 340 ones that they're only the 8-pin version. They've got the integrated oscillator into them, but maybe it's probably just an RC oscillator, so it's not as dependable, but it works pretty good. So yeah, 1117 3.3 volt chip. So yeah, really this is a very simple sort of thing. It's probably something I could easily enough build as well, or anyone could. The trick though is the ZIF sockets. So I'm kind of wondering where this jumper here is to play. Yeah, well, DefPom, it's being a bit annoying so far. I swear I can hear Mo. Set the chip into appropriate slot. Yep, that's what I get told. Well, they make it sound so easy here, and yet, funnily enough, we can't find squat. Yeah, doing the RTFM. Yep. Oh, that's weird. They've got pin 1 back there. Oh. Is that possibly it? Oh, great. I've got... Maybe it's supposed to go the other half. That's what they're saying. Right. Yep. I'm an idiot. Yep. Okay. That's confusing. Well, it's not really, but it's just... This front half... Oh, you can't see. Just show you, because I know someone else is going to run into this. When you come from using this programmer, you go into this one, this is why it's confusing. The first 8 pins on this are for the EEPROMs, the second 8 pins are for the SPI. So you've got to plug it into the second 8 pin. That's why I couldn't find it. Let's try again. Yay, we're reading. Finally, success. It's similar speed to the 866. But yeah, it's interesting that it isn't profoundly better. Now, I don't know. I don't think that's a limitation of the SPI ROM chip, is it? Or is it? Because I thought they'd read fairly quick, certainly quicker than this, but yeah, that's around about the same speed. So I'm going to guess then that they are just using like 115 kbit per second perhaps on the serial bridge. Miles, I'd like to see you read the instructions all the time. How dare you patronize me like that? What next? You're going to tell me how to do an SMC? But yeah, that's interesting, yeah, because you just go by the assumptions. Maybe they could have made it... I mean, they did literally write on the back of the programmer. Okay, so that works, but performance-wise, it's no better. Miles actually reads the instructions, is too paranoid. I don't know. This is a strange side of seeing you, Miles. So let's see if we can search through this. So let's look for SSN. Find. I don't want to replace, I just want to find. Why isn't it finding it? Should definitely find SSN. Well, we'll save it. Save. No thanks, not as root, whatever. Okay. Whoops, yep. Oh, there we go, yep. I found SSN straight away. And there's the serial number, and that is not the serial number of the chassis of the microwaved machine. Yeah. Oh well, okay, well, at least that's one more thing done. So we know it works, but as mentioned, I don't know, who was it that mentioned it earlier? It's no faster than this. The upside, I will admit, now that we've actually worked out what we're doing, is that this has a nice, pretty user interface. But I'm going to have to do... I suppose I can just keep using this. It's a bit of a dodgy setup. I still kind of like this a little bit more. The zip socket's nicer too. But I think I'll put a great big red marker or something over that front 8 pins. So anyway, oh well, yeah. We worked our way through it, stumbled, crashed, burned, destroyed a few civilizations, but we got there. Yeah, the GUI. Alright, stick it in there. Probably should not put that in there. These two need to go into my rapid access box. Alright, that's out of the way. Alright, so that's all the products for today. Isn't it funny how you can order all this stuff? Okay, we only had 3 items. You can order stuff, and then you get to the end of going through it, and you kind of feel like, wow, that really wasn't all that great. So you go off and you buy more stuff to satisfy your urge to have stuff. And this here is, maybe this is just a power only extension, but anyway, it's going in the rubbish. In the rubbish you go. Yeah, it gets like that, doesn't it, DevPom? I think those are my SPI type chip programmers. Trying to find my other box of programmers. Where are you guys? Hiding. Ah, there we go. And then, yeah, I've got, okay, these are all AVR programmers and all different sorts of more programmers, ISP. Yeah, and you just sort of collect them and, oh yeah, there we go. Yeah. What was you? I can't even remember what the hell that was for. You know, if I throw that out, I'm going to need it. I did have some of the proper AVR Atmel ones, but I think I ended up throwing it out. I think it was a clone or something. It wasn't a legit one. It didn't work properly. I may still have my original 3-wire 1 resistor parallel port programmer for Atmel ISP2. Just gotta go check, see where Milo is. I'll be back in a second. Change gloves too. He's getting icky. Then we've got to build stuff. See Milo? Okay. He's in his little... He really likes it in there now. Now I'm going to start building. I've been just checking all the stuff that came in this morning for...
Have you got your water?
My water? No.
Do you want me to get it for you?
Sure, it's in my room there. So today we need to build, I think, at least one batch of ring lights and one batch of USBC meters. I do like this, like I said, I just wish that the thread was better. I'm not quite sure how I'm going to do, because you can't really... I can't think of any way to preload it. I suppose you could put a spring pushing back against this. That would add the preload. And I know it's been a little bit pedantic, but it really does matter when you get this slop and you're trying to fit the chip. You know, you can easily be trying to work on, say, one of those silicon, just those blue-colored silicon wafer die chips. And if that slips and it chips the corner of it or something, you've killed the chip sometimes. Funny that. Chip killed the chip. But to be fair, I suppose this is why instead of paying $12 for something like that, you pay $120 for something that actually is engineered properly. It's still cute and fun. I think, hell, maybe it's just a fidget toy for me now, like a cat. I should try and see if the cats like it. Anyways, let's get to some serious business now. What have I done to my hair? I've just tied it back, that's all. Okay, let's get the microwave out of the way. It's still in its box. Get the DSO out of the way. I've been using this more than I ever have before. I've got a A1706 923 board. It was working, and then I was about to send it back out, and whenever I am about to pack up a job, as in post it out. Oh, thanks, baby. Much appreciated. Whenever I pack up a job to post it out, you test it just before you pack it up, because then it's the most proof you can have that you've done the job right. Anyway, it didn't work, and it's a strange fault because it charges. It gets 20 volts, but it won't turn on. It's stuck in suspend state, and it is not being very nice. So I'm going through with the DSO, trying to find out what rails even try to start. And so far I'm not finding any, other than the suspend state ones. I am not getting any transition rails, like rails that might jump up momentarily. Either that or I'm using this thing wrong, but as far as I know, I've got it on single sequence mode, and it stays on there, and I've tested it with other signals, and it locks, it catches the signal as it transitions. I've got my trigger level down even as low as like 0.2 volts. Nothing's happening. I just don't know what's going on. Very, very annoying. And because I've already been paid for the job, so that makes it doubly annoying. And the person's being really good. They're not saying anything to me at the moment, but I know they're probably going, "Where the hell are you, Paul?" Let's see. Oh, we get to use our stainless steel, metallic stainless steel plate. I forgot that we had all this. I haven't done any manufacturing in a little bit because I did a large amount and then just stopped, because obviously, well, why? I don't want to make too many things at once. Oh, crikey. Stuff's falling out all over the place. Okay, so this is obviously... So yeah, this is stainless steel. It's magnetic stainless steel, because a lot of the stainless steel you buy is not magnetic. You just have to, pick the one you want. Where's my stencil? Hey, Josh Homan. But yeah, I don't like to over-manufacture too many things, because you may find that you've made a mistake somewhere. Yeah, there's just reasons not to excessively build up too many. Like, oh, I did 1,000 of them and now they're all wrong. You think it's funny, but it's true. I need stronger magnets here. They're not really good enough. Yeah, for some reason I've got a tiny bit of lift here and I don't know why. Oh, the stencil is sitting proud and I can't work it out because they're the same boards. I don't know whether it's maybe the hot air solder layer. But it's definitely sitting just ever so slightly proud. So much so that I think I might leave that off. And in fact, this side isn't maybe quite so bad because it's on the tail, for me anyway, it's on the down drawer. So it will tend to compress itself as long as I only do one pass. Oh, come on. And you can't really do this on the edge because it just makes it bow like that. I should just get some circuit boards that don't actually have anything on them. Or find something maybe like this that's ever so slightly thinner. So how we going here? Okay, that's better. It's still there. It's better, but it's the main reason why it's a problem if you got this lift is when you do the pass, it can cause the solder paste to go down the hole and then spread out, which isn't ideal. I'll have a drink first. Yeah, I think my wife might be poisoning me. Tastes funny. Main thing is, as long as the stencil and the recipient of the solder stay synchronized, then I guess we should be happy. Well, now I need solder paste, and I really am not prepared here. I'm sort of like just winging this as usual. Nothing unusual. Solder paste. Oops, sorry, it was a bit loud. Oh, there it is. Probably about 80% of that's just going to go straight into the trash. Or maybe I'll use it for reballing or something like that. I didn't quite get it right there. Definitely didn't get it right there. I'm going to leave it like that. One pass, it's good enough. We're great. Next trick is you can't just, you got to roll it off. Looks good. Now snap it, which is actually a little bit tricky. There we go. Okay, we've got our boards. I need to wash that. Wash it now, Paul. If I don't wash it now, I won't wash it. Ow! Until my finger gets crushed. Put these somewhere safe. And by safe I mean random location on the bench with a lot of trash around it. Sort of like applying type. Yeah, not too dissimilar there, having done both. I can tell you now, I do a very bad job at doing tile grout. I don't know how I've got that indent there. It's annoying. Fortunately, it takes a long time for the paste to go off, as it were. I think most of these pastes have at least a 12-hour working life. Some 24 hours. So I don't have to rush to get to the other. And every time I order a new batch of boards, I actually order a new stencil as well. Because even if it's exactly the same board job and you're just getting a rerun, I have found there is often enough subtle differences that your old stencil is not going to match. And that's really frustrating, particularly when you waited a few weeks. At least for the sort of cheap manufacturing stencils that I get, and the boards. Because this is just your $5-6 board production from JLC or PCBWay and things like that. So you can't expect there to be perfect reprints and things like that. It's just not going to happen. So every time I get boards done, I get a new stencil done. The nice thing is at least they now allow you to set the size of the stencil, whereas before it just came in a big sheet which sent your postage costs absolutely crazy. But now it's much better. So I'm happy that they've done that. Okay. speaking of tiles, I'm in the process at the moment of moving 2 pallets of floor tiles. And unfortunately, when they were delivered over from Italy, we had to get them specially ordered because they all of a sudden decided not producing them anymore. So that was a pain in the ass. We had to get them shipped over from Italy. That was a few years ago. And within about 3 months of us having those delivered, and we had the builders come in to install at least a portion of them, termites had already eaten the wooden pallet, and then they also went up into all of the they went into the cardboard that was used to hold the blocks of tiles. And so we had this 2 pallets of tiles out there infested with termites, and the only thing holding them together basically was the plastic wrap around the pallet. So that was a pain, and I had to, so we couldn't just get a forklift in to pick up the whole lot and move it to a new location closer to the house. I've had to now get the remnants, maybe 5 or 6 tiles at a time, shift it over to a plastic pallet base, and obviously I can't stack them as high, so I have to need like 3 or 4 plastic pallet. Yeah, it's a pain, and I've got to wash all the tiles because I've got termite goop all over them. It's not a big problem with the actual top side surface of the tile because you can just wash that once you've got it installed, but you don't want it on the glue side. Let's see what I'm after. Right, I need a bunch of stuff, a bunch of components, and I need my vacuum pump. I had to laugh the other day. I was looking somewhere, I think it might have been Dave Jones' stream or something like that, and they were talking about, oh hell, what was it? Anyway, they had a vacuum pickup pump, and it was $500, and it basically does exactly what that does. And I was like, crikey, that's quite a price, $500. And they had all sorts of fancy gadgets, buttons and things like that, and I'm thinking, you don't really actually use that. Sorry, contemplating. I can use this. If you're wondering what this is when I went crazy and bought a probe set for a oscilloscope and things like that, all magnetic setup with nicely perfect tensioned little probes that you can just bend over and touch on the board. Very, very rarely use it. I mean, it's a good tool, but you really do want to be using it every week or so to make it worth it. And I dare say a lot of us have a very similar issue in our workshops whereby you have these marvelous tools, but you really just don't use them. I think I might get another one of these plates. Trying to work out what I'm doing here, to be honest. Is this what I want? I do apologize, there is this overhead reflection. I know, easy way to fix that. Still overhead reflection, but less so. Alright, now we need a little components. This is for the USBC meter, obviously. Yeah, that's true, Miles. Very handy for that sort of thing. I'm not quite 100% what I'm doing right now, so I do apologize. Alright, guess we're just gonna go through and start pick and placing and hope I get things right enough. I feel like I need more light there. No. And this time we'll try to remember to put our AVRs the right way around. I suppose the upside of the $500 vacuum pen thing is that you don't have to, you theoretically might not have to battle as much as I do with this one. But still, that's a pretty steep price. Ah, I got it backwards. I actually feel like this bright surface is more of a hindrance than a help. It's making my brain... Yeah, that's better. It's making my brain not be able to see the brightness properly. But what I think I might do is have it off to the side so that I can use it as the sort of like the bouncing platform maybe. We'll see, we'll see. No, still struggling. Be easier if I could do this under the microscope, but it's not really practical. The only way I could probably make this work if I did it under the microscope is to actually go with a 0.5 Barlow. Then by the end of the day you'll be a freaking giraffe. I don't know how people manage to use 0.5 Barlows. Like I said, you get a fantastic amount of headroom, clearance room, working room, but you got to lift your head up so high. I suppose if you set the workbench down, but that's the trouble. It increases the distance between your eyeballs and your hands in such a way that it's still uncomfortable, at least in my opinion. I guess you just get used to it. Use a 0.35. I have to raise my chair to top height. Oh, yeah, okay, yeah. See, I use a 0.7 or 0.66, depending. I was very lucky at the time when everybody was just starting to get into this stuff. It was either 0.5 or nothing. And I remember thinking, gee, I wish that had like a 0.66 or 0.7 just to get that in between range. And then within a week or two, I saw one. Maybe they've always been around and it was just a case of I didn't see them. But 0.35, that's just getting a little crazy. What am I doing? Why have I got... Oh, yeah. And I've got so many of these USBC connectors. That's the other thing when you're doing manufacturing, is that you fear greatly the supplier no longer supplying or making the parts that you use, particularly when it's things like connectors. Yeah, it's the last thing you want to do is go to restock and then you see that they no longer manufactured, or yeah, stuff like that. Stuff of nightmares. So what you do is you compensate by buying way more than you think you'll ever need. And you end up with... And that's how you'll often see bulk lots for sale from closed down businesses and things like that. And that's because they were like, well, we envisage over the lifetime of our production we're going to make 10,000 units. And so you buy 10,000 units worth of stock, and then because you've overextended on your capital expenditure, you go broke. But at the same time, if you don't do it all up front, then you most likely, the universe will decide, now you've got a popular product, quick, make 10,000 units, but you've only bought enough for 1,000 units, and now you're going to have to go and restock your feedstock. And then that's when the no longer manufactured comes up. And the pancake lenses between camera and camera work way better than the ones with the SZ LVT XX models. Pancake lenses. So I'm trying to think which one I'm using. I've got the 0.35 for my camera. Oh, sorry, no, I've got a 0.5 for my camera. Not sure what you mean by the pancake lens. I'll have to look that up. Joseph, you do get the discount, of course, too, but that quickly does taper off. Usually your biggest saving is in the 1 to 100, like if you jump up to 100 purchases, like 100 units or something, that's typically your most significant discount. Beyond that, it really doesn't gain much. The 0.35 I have is for the camera port up the top. It's not actually on the Barlow. I've got a 0.7 for my primary Barlow for the actual main objectives, but the camera has to have 0.5 in order to be able to get a reasonably full frame. Because it's got a roughly half-inch sensor on it, or 1.8. Personally, I'm in a bit of a pickle at the moment because the camera I would like to get has a 1.2, so it's more like 3/4 of an inch sensor. And the trouble is, in order to be able to get a reasonable frame fill in that, the optical adapter you have to put between the microscope head and the camera itself is actually quite long. And so I'm starting to head back to a rooster tail effect on the top of the microscope, and I don't like that because that's a lot of leveraged mass just floating on top of the microscope head. It wobbles around a lot. You pick up a lot of vibrations, things like that. It's this. The 0.35, like I said, it really depends on your camera sensor. Like when I had the 0.35 for the camera sensor and the previous camera I had, it was pretty much perfect. Whereas with this one, if I use the 0.5, oh okay, I see what you're saying, yeah, if I use the 0.5 like I'm using now, then I'm basically not filling, I'm getting an excessively full frame, so I lose quite a lot of what you see in the video recording is a much smaller portion of what is totally there. But yeah, if I switch to 0.35, then I get edge issues, and I don't want that either. So yeah, that's why I'm on 0.5. I just have to make sure that I keep what I want to be seen bracketed a lot better. Sorry about that, bit confusion then. Hey Mark Sutter. By the way, you'll find that if you're doing circuit board work, you'll find that autofocus doesn't really work so well. There's just something about our work that it doesn't like, and I can sort of understand that because the depth of field is typically not good enough. Like if you've got, like you're trying to look at a part like that, then the microscope's depth of field is not deep enough to be able to focus on the top and the board at the same time. And so that autofocus tends to go a little bit spacky. Did I put the resistor LEDs on before? Yeah, if you, like I said, I don't know of anyone who's bought one with autofocus that has managed to get it to work well enough that they are willing to keep it on. Almost, well, everybody that I know that's got an autofocus one ends up turning it off in the end. I was looking at the IMX, which one was it? The 678, but that's the one with the extra large sensor, and I don't want to have that rooster tail effect I was talking about, where everything's just like hanging off the top of your microscope assembly. So I'm gonna go with the 5.8 something, I think it is. Let me just check. I'll bring up my. Oh wait, no, I don't have my AliExpress on this machine. But yeah, there's another sensor. It's better than the 334 because I've got the 334 in this one right now. To be fair, it's a perfectly good sensor, but the implementation in this particular microscope camera is terrible. It just wants way too much light, and I can't give it that light. So yeah, I'm gonna have to cough up another $500 US and get this new camera. The other thing is that the HDMI protocol coming out of this really upsets my capture card. The Coma 4-port card does not like it one bit. It does okay with the Blackmagic card, but the one that I really want to run, the AJA Coney 4, it's like, nope, don't like you. Every now and then it'll be fine for a couple of days, and then it's like, nah, change their mind. We don't like this camera anymore. Get out of here. Which is really frustrating because it's an extremely expensive capture card. And I've had it replaced twice now. Originally there were faults on it. Like I had one where the encoder chips for the ports actually were not soldered properly, and I was like, wow, that's sus. But that was a separate issue. It wasn't actually the problem I was having with the camera. But it was just a bit alarming. I think the problem they're having with that particular card, which swings back around to what we were talking about before, is that the chips that they're using for the encoding are actually no longer available. I've got the wrong angle on my hand here. That's it. So whatever stock they have of those cards is the last stock they'll be making. But it's not a bad thing, because these days, yeah, the chips that they used back then for encoding HDMI, for capturing HDMI rather, they get superseded every 6 months anyway. So it's not really a problem, other than the fact that they have to go and rebuild the board. Yeah, this is turning into more of a booter type stream where it just goes on and on and on, I'm afraid. I'll go into my other office and check what the camera was that I'm looking at. It's similarly priced to the 678, but like I said, it uses the 1.8 sensor. But what the hell? Bloody hell, tiny hair. So it means I don't have to change my Barlow. Not that I care about changing the, not the Barlow, the camera port converter. Wow, Paul, you really suck at putting parts down. Yep, that'll do. Oh, that's what I wanted to look at. So these 301, so they're 300 ohm for the LEDs. Did I use that? I have a feeling I put 150s on these. Oh no, 301, I did. It's funny how you can do things sometimes and not even realize you've done it. I couldn't believe I murdered that person. Yep, 301, cool. Okay, I'm happy with that. Just trying to put these into alignment slightly better because they are a little bit temperamental. Most definitely not intended for this kind of work. Okay, time to get the hot plate. What are we going to use today? We're going to use the big one. Don't slip. Gee. Transferring populated boards around is a little scary. You always worry that you're going to sneeze, slip, something's going to trip you, anything. The fear is real. Alright, let's see, where's our... Newton's fourth law? Okay, that's new. Anyway, the surface tension will do just fine here. Extractor. Okay, now we wait. Give you a bit of zoom in. I'll go and check that microscope number. Hey Mimi. Chewing girl. Looks like I remembered wrong. It is indeed the 678. So yeah. So that's nice. Yeah. So as soon as I get a spare, good luck to me for this, but yeah, as soon as I get a spare couple of hundred US that I don't have any other purpose for, I'll be wanting to get one. So yeah, 678 is the one I want. And I think for me, it's a worthy investment for me because all of my work is captured with the microscope camera, and I need it for archival reasons as well. You know, there's been quite a few times now where having good quality recorded footage has saved my backside. I mean, YouTube is great too, obviously, you know, doing it for YouTube is fantastic, but mostly the legal archiving side of it is what I really want it for. Takes a while for this thing to heat up. We're only at 140, which is a good thing, to be honest. We don't want this ramping up so fast that the parts aren't even warm before the solder melts. Hello, Lalo. Yeah, Joseph, I thought it might have been something along the lines of a joke, and I'm sorry I ruined it for you. That's Paul's fourth law of socializing. Ruin all jokes. Personally, I prefer to put these into an oven, but we're only at 170. This is actually taking a little longer than usual. I mean, most of the time, a full oven cycle that I would do would be around about 7 minutes. So you got the preheat phase. Preheat phase is the longest portion of it. The actual reflow only takes a minute. The 585 was the other one. Yeah, I was looking at. Plug that directly into OBS as a webcam. That's handy if you don't have a dedicated capture card for this sort of thing. Because I mean, capture cards. Okay, the Blackmagic one was about $500 or something like that. The Archer was $1,600. But you can get the cheaper capture cards from China now for $250, $300. I haven't tried one. I imagine they can't be too bad, as long as they're supported by OBS. That is a very wonky one. I hope it... Okay, we can turn off at this point. Oh, that is way off. Messing with my oscillator. The two boards. Oh, messing with the OCD. Yeah. The main reason that they've done that way is because I need more heat on the... I need the extra heat from the inside of the plate to get those connectors up. This is the same board that we've been using, but yeah, it can take the SOT 223 size regulators. That's me doing my best to not completely lock myself out of supply issues. Okay, I actually can smell this starting to cook a little bit. Ah. Alright. Joey does tech pizza delivery. Yep, those boards are hot. I can smell them cooking up that perf board. Alright. Make sure we don't touch the hot part, because that will make me cry. Did I season the board before cooking? I should have thrown some coarse corn grit down. Alright, there's going to be a little bit warm, but they should be okay. Ah, yes. For the most part, Newton's fourth has done its job. Okay, that ground pin is connected on the USBC, on the USB connector, so that's okay. Just looks a little like it's not. No, now that upsets my OCD, I will admit. I really do like my resistor codes to all line up, but I'm too blind to be able to see that. Okay, we've got a bridge there, nothing unusual. It's pretty normal. So that one there is better wicking. no bridges there. That's nice. Again, upside down. Wow, I'm just tormenting myself. Someone says a bridge on the USBC. I'll go and have a look at that. Well, we did pretty good with these ones. There was only that one bridged version. These USB-Cs are okay. Okay, where was that USB-C bridge? Yeah, it's interesting. Don't normally get a bridge like that. But yeah, that's definitely there. On the same board too as this one. Alright, let's get this fixed up. At least this one's easy peasy. Ah, yeah. Not too much flux. We just need enough to slurp out that little bridge. There we go. How do you reduce the chance? Basically, it's a case of reducing the amount of paste you put down bit by bit, but that comes with its own issues. You start reducing the amount of paste too much, and you will get other issues like, you know, just dry connections. Connections that, what I mean by, I don't mean like classic dry solder, I mean the fact that there's no wicking that goes on. I might actually just go through and rework these entirely. More flux required, or do we? No, that's good. Yes, we must all respect the Jason Vilma flux level requirements. Rossmann flux levels are unrealistic. This is approaching Rossmann. Hey there, Moby. Just building some USB-C meters. We also have to build some ring lights. And what I'm doing here is basically just reflowing the solder to make it a bit prettier. Like that. From a technical perspective, I don't think there's really a lot of difference. Electrically, those pins are all making contact. Sometimes you just feel a little bit better if they're wetted nicely. It's one of the few areas where hand finished work can actually be superior to factory work. Like I said, one of the very few areas. what's this? You miss... Oh yeah, yeah. Paul Solansky. He's got his own channel. Yep. I always felt he was a little bit... he was a little bit out of place at Rossman. I thought he was excellent. Yeah, technician. He's an excellent technician. He really knows his stuff. And I think what I really like about him is that he really has a good work ethic. And I felt really bad for him when they shot his monitor, when they were just stuffing around with like Nerf guns or BB guns or whatever the hell it was, and they cracked his screen. If I was him, I would have raged something fierce. I'm sure he did. It doesn't matter that obviously they would replace it. That's not a problem. The thing is, it just shouldn't have been done in the first place. So you don't mess with other people's equipment. Like, I know it was all in fun and jest and everyone was running around enjoying themselves, but yeah, I still think it was just a bit too far. Especially for someone like Paul. I know he took it well-ish. For some reason I keep running out of flux by the time I get to the end. Yep, looks like we need some helping hand here. I'm hoping this weekend I'll get a chance to try out the microwave. I really want to, because that the damage on that board has really stirred up a lot of chit chat. I've got some people telling me that nah, that wasn't microwave, it was just high voltage or high current. But I don't know, I've got my disbelief. It's just too weird that you got so many different completely unrelated nucleation points, and just the way, like some of those areas with the copper, the way it has melted, it's just an absurdly strange failure. Anyway, so I'm putting my money where my mouth is, or where my theories are, and I bought a microwave oven and I'm gonna give it a shot. Hey, you didn't take your solder. You still didn't. What's going on there? That's better. Hey Steve K. Yeah, doing alright. Just having to build a bunch of stuff because I've had people order stuff and I didn't have the stock immediately on hand. To be honest, I do declare on my website to, to always check to see if I do have stock on hand if time is of the essence. Yeah, I don't want people buying my products under false assumptions. Yeah, it was too localized, I thought, agreed. Yeah, the fact that it picked on, the traces it picked on were usually very similar in length and width. I took some more video footage of it last night, and I found there were a lot of cases where it was spark gapping between two dissimilar components, other than the fact that they just simply were the right distance apart. Or at least it feels that way. Obviously I have an inherent bias to believe that it was a microwave, but I guess that's it. That's why I bought one, because I thought, I want to see if I'm right or wrong here, because I just don't feel like it is someone simply pumping 220 volts in it, because I've seen that happen and the behavior of the board is different to what this is. I've seen it happen because I've done it myself to destroy some boards in the past. Intentionally, as in under the guidance, under the request of the owner of the boards. And it doesn't really feel like a lightning strike, because usually I find lightning strikes will take out the input stage, and then you'll definitely vaporize a lot of parts on the input, but that's it. It sort of rapidly dissipates after that. Ended up buying a MB786. I actually don't know myself what Dave's meters are like. I've never tried or bought one. I'm sure. Are they rebadged Brymans or something? I don't know. Someone told me. Well, not entirely rebadged. I know he's added his own stuff, but the base of it, I mean, the core of it. Tesla coil's another possibility. Just leave it sitting somewhere nearby with it. But of course I have had people bring in iPhones that have been microwaved, and that's where I have seen a similarity in the I just got a little bit of IPA and maybe flux in my eyeball just then. I'll be back. Normally I have my glasses on. I did not. Need one of those eyeball wash. Oh yeah, those things are terrifying. Especially when they say remain for 20 minutes flashing, and you're like, I can barely tolerate 5 seconds of that thing flashing my eyeball, let alone 20 minutes. But I suppose if you're trying to flush out some sodium hydroxide or bleach from your eye, then yeah, you're going to want to be there for 20 minutes. At least if you're lucky and you get some acid in your eye, then that's not so bad. Acid is a lot easier to get rid of than alkaline. Caustic soda, oh no thank you. Yeah, very alkaline materials like caustic soda, bleach, sodium hydroxide, that sort of stuff. The problem that we have as fleshy human beings is that when that stuff gets on you, it doesn't want to let go of you. Whereas with acid, you can just throw water on and acid immediately gets diluted and is out of the way. But your alkaline, strong alkalis, strong bases, they're like, nah, we live here now, we're going to cook your eyeball, we're going to make it look like a poached egg. Not that you'll be able to see it. And at least with acid damage, you can usually regrow a bit back, sort of thing. But once you poach your eye with a base, it doesn't work so well. Steve, mine's only the one I bought's only a little 20-litre one, but it will suffice for the purpose. I mean, obviously the perfect test would have been to get another 1706 board and a microwave that could handle it. One theory is that maybe they had a convection oven that they used for drying things and they accidentally switched it to microwave. I don't know. Well, actually no, the thing is that board is not even from that machine, as in it's not the original board. That board's been swapped. We do know that because I checked the serial number and it's not the serial of the original machine. I just need to warm this flux back up. One problem I am running into when it comes to multimeters and things is that I have this strange want to keep buying different multimeters for no other purpose than to just have them and write the software to make them work on Open Broadcaster and things like that. I don't know why. It's a very weird. I'm doing it the wrong way. Stop it. You have about 10 handhelds. I have about 10 handhelds, but they're all the same model. I need to actually give them away. Because when I did the thing for open board data with Rossmann and Repair Preservation Society, it was cheaper for me to buy more multimeters than what I needed to give them away. And so now I've got the surplus of multimeters, and they're good meters. I'm happy with them. They're these ones here. They take 4 AA's, which is great. I love the 4 AA option rather than the 9-volt option. They've got a solid serial port. They've got a really loud continuity. So yeah, I've got a bunch of them. I just need to give them away. Because I mean, I don't need them. I've got my bench meter, my Instax GDM 803041, and I've got one of those, a different build of it. It's the same thing. So what am I going to do with the rest? I don't know. They're just sitting there rotting. The trouble is, trying to give away stuff is actually surprisingly harder than what you expect. I know that doesn't sound right, but it's true. Okay. Right, now we've got to flash these things. Wow. Hey, horse. Been a while. Okay, professional, no keying protection programming. Okay, all done. Get ourselves some displays. I'm gonna be lucky if I get these done in time to actually get them shipped. That's gonna be annoying. I hate the fact that I paid extra. Oops. These things have a backlight module in them. But the trouble is, if I want the one that I really want, which is the one without a backlight module, it's just purely reflective, I've got to buy 1,000 of them. And I'm not quite sure I'm up to paying buying 1,000 of these things. So backlight module it is. I just don't use it. And honestly, I don't recommend anybody uses it. Because believe me, the backlights in this, it's just a single LED with like a acrylic, not even acrylic probably, it's just plastic and reflective foil all around, and it looks terrible. Hey there, Q's. Just saw you slipping in there. Alrighty, let's see. Let's see how we go. Take it from our main one. It's good. It's good. You can also see across on the other side when it tries to communicate with it, like it loses connection, like now it says init trying. I'll plug it in and it finds it, so that's good. Marvelous. very high-tech bonding system for this. To be fair, it is Tessa tape, so you know you've got quality. Personally, I would like it if I could just ship them like this, but I can't. I mean, I know some people would be fine with this. Like, I mean, the one I use myself, it is just bare like this, but I do have a 45-degree like offset stand, and I've just got it mounted on the shelf in front of me. And it just makes it easy because it's slightly below eye level, and I can just switch cables very quickly. But I prefer to legitimately ship them in the shrink wrap that I do. At least that way things aren't getting too damaged. Okay. A big roll of shrink wrap. Where's my scissors? Well, I'll leave it to someone else to make a 3D printed case. I've never really found the need for a full case. Like I said, I've got my little offset stand, my angled stand, but beyond that I just don't see the need. I'll leave it to someone else. But then again, I mean, yeah, maybe if there's a way that maybe if I can come up with a case that is very quick to build them in, I'll look at that option. Oh, don't do that. The biggest thing I hate with shrink wrap, tubing like this, is just the amount of crap that it collects. Like already it's picked up a hair, you know, all that sort of stuff is extremely frustrating. Definitely triggers me. I really need to, what I do need to do is print a 3D guillotine for this. No, that's no good. I mean, I get that some people would be wanting a case, or, you know, just for the... And I suppose that's like, well, there you go. You got a 3D printer and you got the design inclination. It should be fine. But it would be an additional cost and additional time delay. Like I said, I'd really want to make sure it's going to be something that I can literally just slide the units into. And maybe one screw, maybe two screws. Anything more than that, and it's not going to happen. A nice case would finish up, but then that's the word, there's the key word in there, a nice case. And that's hard. And from experience with doing cases for production stuff, it's really expensive. And you go, well, you can get some standardized cases, and it's like, yeah, you can. And then the fun part is when you try to get them fitted for your project, trust me, it's not fun. Been through that process a number of times in the past. Don't really care to do that too often again. Incidentally, no cats really come in here. It's just, there's hairs from carpet and just drifting in from airflow. In this case, I've got an eyelash that's all of a sudden appeared there. But you also have to wonder, like, what is a case going to really bring to this? Okay, you cover up the electronics, maybe. In some ways, I kind of like seeing the electronics. You're not going to be able to print a screen protection on it per se. You just simply, what is a case going to bring, unless you can sort of maybe have a clear cover over the top, but then that's not going to happen either with 3D printing. An acrylic thing would be probably the best. If I had to go a particular way, what I would probably do is have a folded over maybe 2mm acrylic solution. So you would have a piece of acrylic that's twice the width plus something, folded over into like a U-bend, and then you can slot it over there and lock it in. That would be about as far as I would take it. And then you need the standoffs to lock it in, things like that. But to me, that would probably be the easiest route. Alleviate your OCD. Well, you can use your OCD to create a case. So what the hell did that smear mark even come from? I have to wash that off. Also, I would trade cost for an improvement of time is in the sense of adding this takes me 2 minutes per unit, let's say. But if I could cut it down with a case that cost me, say, $2, but it only takes 30 seconds to do, and it's consistent and keeps things protected, then I will take that time cost trade-off. I also need to... Did I peel off that protector? I don't think I did. Probably just going to be easiest if people invent their cases, using STL format, 3D models or whatever, and just share them around. Because everybody's going to have different wants. But, like I said, if a solid casing solution was viable for $2 or so, then I'd take that. I mean, I'd gladly give up the fact that I've got over 1 kilo of shrink wrap, because I can use this for things like 18650 batteries or something. That is a sunk cost. It doesn't matter to me if I discard it. What matters to me is how long does it take me to do these now, as in whenever I do them. Print cost 20 cents, right. I would also not take off the protective front if that was the case. Because the only reason I take off the protective front film on these is because they're going into the shrink wrap. The printing being slow isn't an issue, because you just set that to run, overnight or whatever. You just have them pre-made. That's a time element that you pass off. You can do other things concurrently while they're printing, I guess is what I'm saying. Alright, let's get some verification tests here. We get ourselves a you know what, no, I'm not going to use that. I'll use my own phone. We've still got the frickin' LED lamps to do. Oh, what's the time? Oh man, it's 2:30 already. I am going to struggle to get this done by today. Okay. Okay, so that one's working. You really do have to test every single, each one individually. We're not in a position where we're selling enough that we can just make them, have them pass basic tests and send them out. You really want to make sure that each one is verified. Okay, that's good. I actually do that with the STL libraries for the ring light already. So yeah, adding it for the... I think I already did put the angled offset holder that I've got here. If I haven't, I need to put it back up. or need to put it up. Because I prefer it being mounted on the shelf here so that I can just look at it. And it also means when I'm plugging cables in and out, I don't have to hold the unit itself. I can just pull the cable and the shelf holds it. Okay, that's all looking good. That's a lot of work for 4. I'm glad the software auto negotiates a new connection. Okay. Sorry, I just got to answer a question here. How much to put a new battery in iPhone 11? Oh, geez. Alright, ring lights now. Oh man, I am hungry. Defcon helped you, he said capacitor. What? What was the original problem, by the way? I can't even remember why you wanted to get in contact with Defcon. I've forgotten already. I'm terrible. My focus on remembering things like that is just terrible. It's intentionally terrible. I'm not going to lie and say, oh, I'm just not a person who remembers these things. I intentionally don't put the effort into remembering a lot of that kind of stuff because I'm like, well, I'm busy remembering everything else. So it comes across that I'm a bit flippant, don't care. It's really a case of I just got to focus on remembering other things. I mean, I don't care. Alrighty. Okay, ring lights. Guess we'll do 4 today. Oh crikey, are we running out of jacks? That's the last thing I need. Yep, we're running out of jacks. Well, guess I better order another frickin' 1,000 of them or so. Oh, that's why I've got that. Yep. Yeah, I think that's it with a lot of things, Joseph, is that I know that with other things that I don't remember or bother to remember, I can always relatively quickly regain that information as it's needed. Okay, where the hell's my stencil for this? Somebody stole my stencil. Ah, there you are. I just realised I haven't actually tried the stainless steel board with this stencil, so looks like we're going into experimental phase again, folks. Everybody's like, "Oh man, not the experiments again." So sorry. That's the way it goes. I do need to polish, not polish, actually anti-polish this. Get that mirror finish out of it. Okay, cool. Difference with this one is that it's only a single unit. This one, I feel like it's less effective in the sense of, the setup doesn't really make it worth it, because you're going to just do one pass and then lift it, and you only got one board. So in many ways, you really just need to lock it and yeah. There, just lock it down, done. It does mean I'm going to need quite a bit more paste again. Still got our paste from the previous one. Yeah, that's good enough. There's no point trying to do multiple picking up these is a lot harder than you anticipate. Finding a safe space, safe space is even harder again. Trying to get an idea of how much squeegee underneath. It seems pretty clear. don't think I want these little ones. They're not really adding much to the situation. Seems like essentially I just need the big one to lock it down, and yeah, I don't even need that, to be honest. Okay. Yep, slightly messed up there. Yeah, messing up. Yeah, starting to smudge out. I'm not worried about insufficient paste on the LED pads. Honestly, I feel like next time I do the stencil, I want to have it such that the holes for those LED pads are actually smaller, because I feel like there's just way too much paste going through. Part of that is because I don't have it completely flat, so the thickness of the metal really is probably actually correct for the task, but anyway, because I don't hold it 100% flat, it ends up squishing more in there. It's drinking paste, this thing. Well, Joseph, this is sort of like my jig to avoid MDF jigs. Yeah, that was much cleaner. Because the trouble with things like the MDF or particle board jigs and things like that is that it's a once-off type thing. You build it and you can't use it for anything else, which is fine if you're doing lots of the same job, but I'm generally not. Like, I might end up doing 100 of these and that's it. So this kind of technique seems to be working. It's more a case of just getting used to it. Whereas with the USBC meters, because I had it was 4 units in the one stencil, so that was a little bit different again. Okay. I think I'll add a little bit more paste again. I think the problem I had with the second one was that I was just too starved of paste. And so when you're starved of paste, it doesn't fill the gaps enough, or even at all on your first pass, and then that makes you come back and do more passes, which causes you, see, like that there was a 1 pass per half and it comes out fine. Okay, so that's good. A lot of this is just working out what techniques are going to work for you. See you, Steve. what I really should do is start putting keying holes into the stencil. It doesn't even matter where I put them, but if I have like holes there, then I can probably drop some magnets in, or just anything in there, and that will help lock it. It won't help it stick down, but it will help at least lock its position quicker. And if that doesn't work, that's fine. I've just got some extra holes in the stencil, but they're not going to cause any trouble. But the biggest problem does seem to be simply keeping the stencil planar, flat and planar to the actual PCB. Okay. Okay, build time. Greg, more drama. You have the worst of luck, it seems, Greg. You really do. It's almost like you need to move country or something. Once again, I've forgotten which way I want this orientated. They do tell you on the data sheet for the components that you order which way these LEDs are orientated, which side's cathode, which side's anode. So it's not their fault at all. I'm pretty sure anode's towards the holes. Yeah, big pad towards the holes. Good. Okay, let's get our first one. Let's get our suction device. Right, so big pad. Damn it, big pads are on the outside. Right. So it actually means holes are best closest to me. So pick that up. Yep, big pad towards me. Okay. No, where's my 7805s? Who did that to me? I see you call it Big Clive takes apart a lot of stuff lately. Okay. Right, yeah. Crikey. Hope I've got some 7805s floating around. I should do. Yeah, we do by the looks of it. What have we got here? Big butter bag. Well, sure looks like 7805s. I hope they are. Because if they're not, it's going to be fun. That's about all I can fit in that. Yep. So we accidentally ejected one. Right, good-o. Hopefully I'll understand my own message next time I use it. Hey, charge show. In this case, no, I'm now building my own stuff. I've sorted out the AliExpress stuff, and now I'm manufacturing my own stuff. It's a slowish way of doing it, but yeah, well, I don't really want to make the jump to ordering 1,000 units or 10,000 units of this stuff. Yeah, the problem with JLC and things like that is that you still have to get them to use the right parts. And it's not so much of an issue with most things, but the big thing with this particular light is the quality of the LEDs being used. They have a very specific set of parameters that I don't want meddled with. And even if I tell JLC and others exactly what I want, I can't guarantee that they won't substitute. Even if I say don't substitute, there's no guarantee they won't. And what I'm fearing is that we'll end up with a situation where they send me 1,000 units of whatever it is that I've built that have an issue that can't be resolved, or they have a quirk in them, or yeah. Anyway, the point is, it's a trust issue. With the USBC meters, that's less of a problem. But for these LED lights, yeah, I'm not really at the point where I'm willing to take that risk. Recently went up to Bunnings, grabbed some Vela brand solder rather than getting out of the electronics store. Oh, okay, so you actually got genuine Vela. So see we have a fellow Aussie here with the Bunnings. Yeah, man, back. Yeah, generally flux and solder from AliExpress is typically going to be an absolute disaster. I have tried some of this stuff. The the solder paste you get in the little containers can be okay. But aside from that, yeah, I don't have the greatest of faith in what you get. This Raspberry Pi had an issue where they swapped out an RJ45 socket for one that was just a couple of cents cheaper but didn't work with other components. 10,000 sample run. Whoa, yeah, that's the sort of thing I'm worried about. And it's not so bad if you've got the deep pockets to support that kind of thing. And that is not what I've got right now. To be fair, although this could be a self-fulfilling thing, I don't get the order numbers to justify getting someone else to manufacture them. If I was dealing with 10 a day, then okay, I would start looking abroad. Hell, even 5 a day I would start looking abroad, because that's 150 a month roughly. Okay, that's going to be potentially marginal. In fact, that's probably about the right amount of paste that should be on there. Okay. These are ring lights for microscopes. So they fit up. I can't show one at the moment, but yeah, basically they sit just underneath the microscope up on the lens assembly, and they project light down so that we can do electronic repairs or whatever else that we're going to be doing. And the reason why I've ended up making my own is because the ones that you typically get with the microscopes that most people in this field are using, they generally have very poor, just put this down. They generally have very poor color rendering index. They also usually are made up of like 100 or 150 of the little clear 3mm LEDs. And it creates a lot of high intensity, monochromatic looking speckles and what's the word I'm looking for? Anyway, the quality of the light is comparatively poor. The other factor is that the lights that you do get with these microscopes by default have a very broad body, and it becomes a problem when you're using, when you're trying to do hot air work, like in using one of these things to heat up part of your board, and you're trying to get as above the parts as you can, but if your microscope is in the way, it forces you to have to go at a bit more of an angle. Now, the one way they fix that is they said, well, they start selling nozzles that had a 45-degree angle. Trouble is, when you put those nozzles on, you lose a fair bit of efficiency. It's not quite as good. So by going to a narrower body light, then the push out from the center line of the microscope is far less, so you get a far more upright handle. Same with the soldering iron too. And there's, yeah. Anyway, so they're the main reasons why I did what I did. Originally it was just for me, but then a few other people decided they wanted one too, so production started. Yeah, I may as well put my 7805 down. I just realized that the last batch of caps I put down on the other board were 1 microfarads, not 100 nanofarads. It's not a huge issue, but I am going to go back and put some hundreds in their place. What the hell is the matter with me? There we go. So we're almost at the point where we've got one more to do, and then we can do the reflow. Okay. Actually, you know what? They're going to be fine. Fortunately, at least ring lights are fairly quick to make, unlike the USBC meters. I mean, okay, I've got to put the 3D ring adapter on and things like that, but they're still quick to make. And then we've got to cook them. This board has way too much paste on it. Hello, why am I short of some... Three lights short. Clearly I did not know how to count on the day that I cut that strip. Just gets better, Paul, just gets better. How am I soldering them on? What we've got down here is a solder paste. It's like toothpaste. So you can see, by the way, this is also using a ring light. Alright, so we've got, let's put down the driver. Okay, so they're just little blobs of solder paste. So basically it's very small balls of solder mixed with a little bit of flux. And that's why it's got a paste-like consistency. Yeah, just got to check that I've got the, okay, that's right. Then we just put it on there. It doesn't have to be perfect, because what happens is when we cook this, and that melts, then surface tension comes into play, and surface tension dominates, and it just pulls everything into place. Which is very handy. So you can have stuff way off center like that, and the reflow process will bring it all back in. And we'll be doing that just as soon as we finish this one. Okay. Now we'll bring out the cooktop and do our cooking. This isn't actually the proper normal way of cooking these, but we're doing it because we're dodgy. No, we're not. Normally I'll put these into an oven, but when I'm doing live streams, I do it on the cooktop like this. I just realized this will actually be the first time that I am doing a set of 4 on the cooktop. I haven't done the ring lights on the cooktop before. Not this one anyway. we'll see how that goes. Angle it towards the extractor. Yeah, these actually should move over a little bit. Power on, extractor on. Now we wait. Now this should cook a little bit quicker than the other devices I just cooked, because these are made of aluminium, and so the aluminium conducts the heat through very quickly. It gives us time to start packing away our stuff. Clean as you cook. Then when that's cooked, we test them. We then have to install the rings. Alrighty, what are we at? Oh, we're only at 67 Celsius, so we got a long way to go. It'll be upon us before we know it. .94, 95, so we're going to get to around about 180, and that's when things will start happening. It will get quicker as it goes. Yeah, we're already at 105. Zoom in for a better look. There we go. You will notice the change when it happens. Do you use leaded solder? Yes. For small scale production, custom jobs, things like that, we're permitted to use leaded solder. We can do lead free. We use a substance, well, I use a substance called SAC 305, SAC 305, and it's not too bad as a lead free, but if we're able to legally get away with it, then leaded solder is definitely preferred. It's somewhat more durable as well. Okay, 160. Now it's 160 by the front panel. This isn't fully calibrated, so it could be anything. Plus we have a cold draft being drawn across it for the extractor. That stuff should start happening soon. 183 is the melting point of this stuff. It'll start smoking. Yeah, you can see the smoke starting to happen. Yep. And things will all of a sudden, you can see them transitioning now. And the nice thing is it pulls most things into alignment. Now we have to watch the outer edges, make sure. Okay, we can turn off at this point. That looks like everything's reflowed nicely. Alright, let's get our transfer plate. Get those delicious morsels off the plate, off the board. So they're still smoking off pretty strong. I might... might give them another minute. This is the problem with using the hot plate, is particularly when it's a hot plate with a lot of thermal momentum or inertia as this, as that even when you turn it off, the temperature's still going to be rising up for a bit, and then you got to wait for enough heat to dissipate so that you can move these boards without the parts getting knocked around. Now I can tell most of that is actually still liquid. It's got to be transitioning any second. Whereas if it's done in a proper oven, as soon as it gets to the point where things have reflowed, you shut the oven down, you blast cool air into it, or relatively cool, and it brings everything back down to temperature very quickly. Which is why I should really use the oven. Like that. Exactly my point. But the problem is, you see, I don't want these on here for any longer than they have to be. As long as you don't actually touch the parts, they won't really go anywhere. What doesn't help is that the boards are made of aluminium, so they really do keep things hot. Alright. They should well and truly be okay now. Yep. See where that one that I knocked was, if we can even find it. There's a reasonable chance it actually just went right on back. Yeah, that just went right on back wherever it was. That's fine. Alright, let's program. Okay. Just took me a bit to remember where my source code was, the right one. Okay, UPDI. Programmed. Whoops. Someone didn't press hard enough. Okay, that one doesn't want to play ball. I see we've got a cap that's drifted off, so oh, we've got two caps. One tombstoned and the other tried to tombstone. Joy. It shouldn't have stopped it from programming though. Yeah, I was right. Okay, so we've got tombstone on that one. Oh, good. Okay, so the chips are programmed. Now we're just going to check for defects in the reflow process, which are entirely normal. I'm just telling you it's entirely normal so that I don't look bad. Okay, so that's good. The biggest issue is always this chip here, of course. You've got two things to make sure we see is we've got the pin 1 dot in the right place. Okay, so there's that, and there's the tombstoner. Let's check the others first, and then we'll come back and fix up the tombstone. Okay, so that's good. Alright, that's good. Okay, so tombstone and not quite there. Extract it back on. Come on, heat up. I'll add a smidge more solder onto that, not a lot. That's better. Alright, now we've got to get the tombstone down. Small amount of flux. Oh, this is not going to be easy. This is on the ground pad. Or was it? Nope, that wasn't the ground pad. I will say is definitely one of the great pains with using these aluminium substrate boards is rework is difficult. Unless I go stick it on another hot plate. Hey laptop. Okay. Now we've got to clean that up. Whoops. There's that one. Alright, time to get ourselves a 24 volt adapter and see if these things fire off. And hopefully in the way that we want them to. And not in the explosive way. Yeah, we don't need that today. Okay. Alright, so put your sunglasses on. Okay. Okay, that's good. Ooh, we got a segment down. Okay, that will be because the controller has got a pin not quite soldered. And that's not even working at all. Wow, our QC sucks today. 2 of them? That's unusual. What have I done wrong here? Okay, well, we can fix that up at least. Okay, I can definitely see that. Yeah, that left-hand one right there. You can see it did. Those two are fine, even though there's no fillet. They're fine because they are contacted, but that one definitely is not. So to resolve this, we're going to use hot air assist along with a nice little soldering iron. Yeah, multiple reports on the QC for sure. Just going to put my nozzle back on. I'm only going to go 230 on the hot air assist. I don't want to upset the LEDs more than I have to. It definitely helps when you have the hot air assist. If you try to do that without the hot air assist, it really will not. That solder will not take, it will stick. It'll do all sorts of things you don't want. Alright, there we go. All of them back. That's good. Okay, let's see what's going on with these ones. I mean, yeah, they're sparse, but I guess we'll just do the same on both sides. The person who asked before about how to stop bridging and things like that, well, this is kind of the other end of the problem situation that you encounter when you try to stop bridging. That's definite bridging there. That's because we ran out of flux. There's one side, now we're going to do the other, which is a little bit trickier because we've got those components in the way. That is actually quite a bit trickier. So we might have to switch to the micro pencil, which is going to be more difficult. Geez, that was loud. Yeah, I'm deliberately leaving the solder stick there. You'll see why in a second. Not to melt you. That wasn't the intent. Okay, I need to get that out of the... Right. Okay, let's get back to the hot air. Clear away the bridging. Fix up our mistakes. Oh, it's ugly. It's so ugly. More flux. Just cooling it off a smidge. Okay. Right, let's see, hopefully this time. That's better. By the way, the flashing when it goes to full brightness, that's intentional. That's to let you know when you're using the light that, hey, there's no more brightness to be obtained. Okay, and the memory function worked. The memory function is that whatever you leave the light at for more than a couple of seconds, it will pop that into its memory and it will recall that setting the next time it's power cycled. And you switch it on. Okay. Alrighty. We've got to see what this one's doing. This will be probably the same thing as the previous one. Although, not really, eh? Oh. Well, yep, that'll explain why. That resistor there is very much required. Don't know how I missed that. I must have been talking to someone. Okay, I'm gonna see if I can hot air this one. I think I might need a little more punch there. Okay, we'll go 390, 410, okay. 41040. You shall not run away. Wow. This is what I mean. If you've got to rework these boards with hot air, it is a major pain. Don't be like that. It's gonna cook the flux. And I'm gonna touch that up manually. Not happy with how that looks. Anyway, yeah, this resistor is required because it sets the maximum current for the LED driver. Does that pin 1 look a little bit sus to you? I think it's worth us, while it's hot, we'll just dress up that pin 1. Maybe with a little bit more solder. Yeah, that's better. And again, wash it off before it gets too encased. Wow, did not do any repair jobs today, it seems. That's not good. Alrighty, let's hope this one goes. Wee. Okay, max, min, medium. Cool. Okay, that's it. All units now functioning. Now we've got to add the heat sinks, and yeah, people will look at these devices and go, there's not actually that much on those ring lights. You're charging a fair bit for them, and they're not wrong. But there's a certain, certainly a fair bit of labour involved, and you got the add that on. There's more than what you really anticipate initially, which is why you try to just do it in batches. You get that batch of boards out of the way, and you're done. You're happy. Go back to pretending that you're making money off fixing laptops. This is a new transfer tape that I've started to use. It's thinner than the other stuff, so theoretically it should give us a slightly better transfer rate. Should and does isn't always a match. SDG Electronics. Who's SDG Electronics? I guess I don't know because they went down. Yeah. I mean, there's some improvements definitely that I could make for this in terms of dispersion of the light, things like that. But overall, I'm certainly a lot happier with this for myself than what I was with my Amscope 144 ring light. Need to find a better way of doing this. I could get a narrower roll, but the trouble is then I don't get the full coverage of the heatsink. So I'd rather do this where I'm trimming off a little bit of the thermal transfer than have a only partial amount. I mean, yeah, maybe it's not going to make a difference. Maybe it's a case of the amount of heat it's drawing up is already more than what it can dissipate. So, I don't know. Steve Gardner is his name. He's a Brit, background electronics engineering, makes very cool stuff, but he's oh, okay, yep. So I suppose in a way is similar to what I'm doing and what Harold does. You know, we're all sort of these, well, I don't know how big or small he is, but sort of on the smaller scale engineering, manufacturing. Right, time for the rings. Maybe he chose JLC PCB and not PCBA, so he's on the damn it, I use JLC as well. That's not good. Oh crikey, I can't even remember what screws I'm using. 2.5, 2.3, I think they're too big. I'm pretty sure I use a 1.7. Which is probably why, so they're the same type of screws, but I use a 1.7 size. So I'm guessing it's going to be in the other box. And I was correct. Wow, looks like I'm running out of those too. Better order some more. The only pain with these particular screws is that they're not magnetic, and so it's a pain picking them up, getting them into the right place. Okay, done. Find JLC faster, but they won't do as advanced services PCBWay. Can't do blind buried vias via JLC. Oh, okay. So like between, say, if you want to go layer 2 to layer 3, they won't let you do that. Are they making you have to go the whole way through? So you always have to go, even if you don't connect it on layers 1 and 4, you still got to run it through layers 1 and 4. Is that how you get around it? Yeah, I've noticed that a lot of people, even people who aren't actually doing manufacturing of anything like that, have got one of those two camps as their sponsors. I don't bother taking on sponsors because there's always stuff. Yeah, understandably, they give you money, you've got to give something back. It's not a free. You don't get a lunch for free. But I'm just not willing to pay for that sort of thing. It's like, no, I'm done. Okay, I can't use this blue one. This is. What happened here? This is a special one. Alright, looks like I'm going to have to make another blue. Oh, where am I? No. Joy to the world, I already prefabbed a bunch. Right, JLC we're going to do through hole, right. Well, at least it's possible-ish, but yeah, I get it. Like, if you've got a BGA floating above that area, the last thing you want is being forced to have to run the drill all the way through. So I get that, yeah. Fortunately, I don't do anything like that myself. Okay, that's it. We are done for today's production run. So we've got 4 units of meters and 4 units of lights. Now, so what's the time? Sheesh, 4 o'clock. I've got probably just enough time to go off, get these packed and shipped out before the close of business. Plus I've got to go get some wood so that I can set up the cat house shelves. Yeah, it's going to be fun. I mean, at least I can get the cat house shelving wood tomorrow, but I would like to get it done today. Fun. Alright. Okay then, folks. Thank you all for watching. I am out of here, and yeah, thanks for sticking around for the last, God knows how long this was, about 4 hours now? 4 hours, 15 minutes, probably the longest stream I've ever done in a long time. Thank you very much. I'll see you all later. You have a good time. I'll see you next time. Don't need screws in the rings, they're already done. Already pre-made. I have them all set up, ready to go. Already done. Catch you later.